So today we're going to be learning about reducing fractions. You have already studied greatest common factor. So for instance, if you have two numbers and you want to find the greatest common factor, if your numbers are 8 and 12, you can use your divisibility rules to find out what is the greatest number that can go into both of them. You can apply that to fractions as well. So let's say instead of just finding the GCF for two numbers, the 8 is over 12 and it's a fraction. Then you would use the same method. You would find the greatest common factor of 8 and 12 to reduce it. One way that I like to do this is called the ladder method. So I would take the fraction and I would write it side by side, like with a slash mark between, and I would put it in like an upside down kind of like division house. So my top number would go first, my numerator, slash for the fraction, denominator. And then I use my divisibility rules to make up a number that can go into 8 and 12. Well, 2 can. 2 can go into 8 4 times. 2 can go into 12 6 times. And this is still a fraction. So then I think to myself, is there a number greater than 1 that can go into 4 and 6? Yes. 2 can, again. 2 can go into 4 2 times. 2 can go into 6 3 times. So I know that 8/12 in lowest terms is going to be 2/3. Maybe you already knew that 4 was a number that could go into 8 and 12. Maybe you already knew the GCF. GCF's over here. If I do 2 times 2, 4 is the greatest number that can go into 8 and 12. So if you already knew that, you could just divide by 4, and you would get 2. Divide by 4, and you would get 3. So 8/12 in lowest terms is 2/3. Okay. Let's see if we can practice a few more. Let's look at, let's look at number 8. So if you're looking at number 8, you should be using your divisibility rules when you look at 9 and 36. And you ask yourself, are they even? You start to go through your divisibility rules. Well, they're both not even. 36 is even, but 9 is not. So 2 is not going to work. So then what's the next divisibility rule you can use? You can use 3. Because 3 can go into 9, and 3 plus 6 equals 9, and 3 can go into 9. So if we had this, we had 9 over 36. You go through your list of divisibility rules. If 2 won't work, you use 3. 3 is adding the digits. And as we just said, 3 plus 6 equals 9. And 9 is divisible by 3, so both of these numbers are divisible by 3. So you're going to divide by 3 this time. So 9 divided by 3 is 3. 36 divided by 3, you might have to do a little bit of work on the side to see what that's going to be. If you don't know your multiplication facts, but you could just think 3 goes into 3 one time, 3 goes into 6 2 times. And is there anything that can go into 3 and 12? Use your divisibility rules. Can 2 go into them? No. Can 3 go into them? You should know that 3 can go into 12, but even if you didn't, 1 plus 2 equals 3. And 3 can go into 3, so 3 can go into 12. So then you reduce it again. Divide by 3 again. Ooh, that's a little bit thicker marker. And you should get that this is 1/4. Now you're going to try some. I don't know why it's breaking up like that. You're going to try some on your own. I'm going to pick maybe 2 from here. Why don't you try 9 and 12? Try these 2 on your own now. Let Miss Gardner or myself check, and then you'll be ready for the next activity.